Hello. Hello and welcome to this tutorial in which we will learn about unions, and this video has been recorded as 720p as most recent videos have been, so please watch at 720p. And as you know, my name is Shankar Dayal and I once again welcome you to this part of C programming series. Now structures are very much like unions, as you can see from this, or rather I should say unions are very much like structures. It doesn't make a difference whether unions are like structures or structures are like unions, but anyway, so I have a char C and I have a short int si. If we remember our discussion, then the size of union should be more than sum of size of these two. So this is 2, this is 1 byte, so it should be more than 2. So ideally it should be 4 bytes, right? So this is our capital U, the type, and then I have declared an object of type U, a union object, and to the short int I have assigned 260. Now remember, it's a short int, it will occupy 2 bytes, so one of the bytes will be 256, that is 1, and the second byte will be 4. Okay, so rather I should say one will be 256, another will be 4. Okay, now I have casted the address of short int to C, so it will point to either of the bytes. We don't know to which one it will point. Now I have taken this pointer C and put it into u.c, and in the print I am printing size of u, and then I am printing short int, and then the u.c, and then I advance the pointer by 1, and then I print that also. Let's see the output. So 2, 264 and 1. Okay, let us decipher it. Okay, so where were we? Okay, so this is 2, size of is 2. Now the size of the largest element is 2. So from this we can conclude that the size of union is equal to size of its largest element. So this is 2. Now this was 260, no problem with that. Now u.c is 4. That also we can understand by understanding the fact that my machine is little endian, so the byte orders are reversed. Therefore when you cast here and assign this, it is pointing to the higher order byte. That is, higher order byte is at the lower order address, and this is star C plus 1. This is lower order byte at higher order address. That's what is 1. So this was pretty easy to understand. So why this was 1, I'll explain a bit. Okay, so when you split this, this becomes 256, right? And a char is 0 to 255. So 256 would be how much? That should be again 0, I guess. So we can verify that also. That should be, it is a signed char, right? Char, I always mess up these things. 256, this would be the value. So if you print its decimal value, so I mess up the 2's complement form, I just can't do it. Okay, okay, so it should have been 0, but it gave 1. Okay, so C plus 1. Okay, this should be minus 1. Oops, this was higher order byte, u.c. Let's try that. Okay, so now we got 0. So higher order byte at lower order address and lower order byte at higher order address. My mistake. So it should have been C minus 1. So we see how the endian-ness of the system affects. Now if you run this program on, let's say, a RISC machine which is which follows the big endian or the network byte order, then this will not work, because then the lower order byte will be at the lower order address and the higher order byte will be at the higher order address. So by seeing this, you can determine the endian-ness of the system by looking at the output of this. You don't need to print this at all. For example, u.c. So I also remove this. Now we compile and run. Oops. Okay, so 4 is the higher order byte. 4 should have been at higher order byte, but it is coming in the lower order address, therefore the machine is little endian. So that's how we can determine the endian-ness of the machine. Now the uses of unions is a bit tricky. Where to use what? So what I'll do is I'll find out some examples and suitable examples, I would say, which will demonstrate practical uses of unions. These are mostly used in embedded systems or where memory is at premium, and also in operating systems and things like that, and also for creating those bitwise OR gates. We will come to know about bitwise OR gates, what are those and how to construct those. So we will know about them when we do bitwise manipulation. So with this, the discussion comes to an end on uses of unions, and I hope you have enjoyed the video. And as I always say, you can hit like if you like, or you can hit dislike if you dislike. Thanks for watching the video, and keep programming so that you can become a better programmer. Enjoy.